Hi everyone, we are from Mercu Buana University. We would like to presentation about review a journal. First member Hasan Abdul Halim, Leni Oktavia, Ikhsan Mansyur, Iqbal, and Syach Rafi. Please enjoy our video.
Here we will review and explain about the journal entitled Development of Virtual Reality Support to Factory Layout Planning. In the table beside it, it is explained that this journal was created since 2019 with author named Lian Gong, Jonathan Bertland, Vas Bertland, John Johansson, Shipping Wang, and Tobias Berjason, which was review myself, Muhammad Ikhsan Mansyur, my friend Muhammad Iqbal, Hasan Abdul Halim, Syach Rafi, and Leni Oktavia on May 31, 2021. The objective of this journal are as follows. In the study, we propose a point cloud-based virtual factory modeling approach for the VLP takes. It incorporates point cloud with CAD data to model that virtual factory with the following aims. The first, to simplify the modeling process by reducing the time and expertise needed. The second, to improve decision making of the VLP text with realistic physical representation that are accessible for every stakeholders to be involved.
Layout planning and the modeling. With the development of computer graphic technology, VLP has done with attention as the three-dimension virtual model enable use experience that is closely related to the real world. This is reported that there are the many three advantages to VLP. 1. The ability to play what if and test alternative scenario with recent else. 2. Moving different actors who are affected by the layout decision closer to the layout decision-making process. And 3. Improve the decision-making process for the both quantitative and qualitative perspective, give the range and the flexibility the virtual model can improve. Modeling virtual environment. Among the various attempts, the modeling the virtual environments to the Maya approach can be identified based on how the virtual model is created. The phrase approach transfers existing physical visibility into virtual objects that draw devices such as the camera or the scan. Other approach modeling facility complete virtual in the computer use complete articulation of the CAD and the software or virtual reality modeling language.
Virtual reality or VR systems can also be categorized as 1. Desktop system, 2. Widescreen projection system, 3. Immersive VR system using HMD. For industrial case, we take one for example that is a Volvo truck manufacturing plant. A Volvo truck manufacturing plant in United States was selected as it was facing challenges in the alignment of master process across its global plants. And then, for implementation to apply in manufacture, they used 3D laser scanning. It was used to obtain a cloud representation of the factory and produce a total of 82 individual scans, covering most of the main assembly lines in the factory. After that, for evaluation the system, they are guided through a short training, a scenario, and then presented with a factory VR model as shown in figure 1. They are asked to complete the following open tasks about 1. Navigate in 3D point cloud virtual factory and then change the layout. 3. Save and load the new layout. 4. Provide input about the layout present in the system based on their expertise. And then feedback was gathered for a further improvement of plan layout changes.
Feedback was gathered for further improvement of planned layout change. An open-ended questionnaire and a closed scale rating were used thereafter to gather their feedback on the effectiveness of this proposed approach. And the discussion value. A hybrid approach combining point cloud data with 3D CAD models to build a virtual factory for the layout planning has been demonstrated and tested. The results show that this is a promising path to efficient and effective education support in redesigning the plan layout with the following advantage. While studies have shown significant benefit of using point cloud-based virtual factory modeling for layout planning, there are many identified challenges that need to be resolved to ensure a transition from a conventional approach to a virtual layout planning approach. In this section, the challenges identified are discussed and direction for the future research.
The conclusion is, in this paper, we propose a cloud-based virtual factory modeling approach for the VLF text. The proposed approach is exemplified and clarified through the industry case. The case results show that a point cloud-based virtual factory modeling approach can create a realistic virtual model for the VLF text. With an immersive HMD and traceable controller, one can easily interact with virtual models to perform VLF tests. Realistic virtual models and natural interactions impart the required expertise, which allows stakeholders with different backgrounds to actively engage and contribute to new layout designs. It is debatable whether the proposed approach simplifies the virtual factory modeling process, such as the limitation discussed in the previous section. In particular, point cloud data processing is still complex. However, with the development of machine learning in the field, it can be improved in the near future. For further improvement, research can be carried out in areas such as objectification of point cloud data using machine learning, 3D data compatibility, user-centric industrial VR application design. Thank you for your watching and see you on top. Goodbye.